that you don't have a formula for. In other words, if you have a circle, you know a formula for the area of that. If you have a trapezoid and rectangle, square, what happens if we have an area something like this? It's not one of the special ones. How can we find this area? Well, this is where we can use calculus. First of all, let's look at some concepts. The old way, before calculus was worked out, people would have to come over here and work out, make a very small rectangle here, and then work out another small rectangle, and work out another small rectangle. And you would have to then, I'm going to enlarge these, draw a rectangle. Now you realize that you're missing just a little part of the area. But if I would figure out this area of this rectangle, which is the width times the height, and then I sum up this rectangle, and the next rectangle, the next rectangle, the next rectangle, the next rectangle. All right, now if I make 5 rectangles, I'm going to miss it some. If I make a large rectangle and then another large rectangle, I am missing that much of the area. Okay, so you're missing some of the area as the larger the rectangle. But if I come in here and make this rectangle extremely narrow, very, very small width here, then I'm not talking about like right here where I'm drawing this large rectangle and this large. I'm not talking about missing very much of the area. So if I can sum up all these rectangles that you would end up drawing, sum up all those rectangles, then I would have the area underneath that curve. Well, we're not going to take the time here to prove or to explain the calculus, but I do want to explain the concept of calculus of integration. Integration is the summation. Integration is the summation of all these rectangles in here. So, what we're going to do then is this. We're going to write the area of one rectangle. One of those rectangles. We're going to write the formula or equation or the concept of the area of one of these rectangles. So I want to come back here and forget about all these other ones, and we're going to find the area underneath this curve by drawing one rectangle and writing the formula for the area of that one rectangle. Well, the area of that one rectangle is its length, and we're going to call that y top minus y bottom, times its thickness, and we're going to call that dx. Now, what I'm saying is this. Whenever you go to find the area underneath a curve, okay, then you draw a strip, a rectangular strip here, and if you draw it up and down this way, then its length is y top, whatever y is equal to up here, minus y bottom, whatever y is equal to down here, times its thickness. And its thickness in this, when it's up and down, its thickness is dx. So the integration of that rectangle gives us all the areas, because integration is the sum of all these rectangles that we could draw in there. Therefore, memorize, 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 memorize. The area is y top minus y bottom dx, or the integration of x right minus x left dy. Now, what this x right, x left is if you draw the strip this direction. If you draw the strip horizontal. And I'll explain some examples where we have to do this. But I'm telling you right now, at this point, you memorize. Area is y top minus y bottom dx, or x right minus x left dy. You just memorize that. And now, with all the examples I hope to have on this tape, I should explain what I'm talking about. Now, I'm going to say one other thing. Y top is what the y is equal to in the curve. For instance, looking at this curve again, y is equal to 4x minus x squared. So y top is what y is equal to. Y top, then, is equal to 4x minus x squared. So you would put 4x minus x squared there. Y bottom is equal to, what's y right here? 0. So y bottom is equal to 0. Now, listen closely. Listen closely. I can use this provided as I draw my rectangles across here, it's touching the same y top. It's touching the same y top. Well, it is. Every rectangle I draw here, y top is the curve, y bottom is the line 0. Therefore, I can work this problem like this. All right, let me just go through now and finish this problem, set it up completely, and work it through, and you can follow there in your notes. Okay, so drawing my rectangle this direction, I have a vertical rectangle, therefore it's the integration of y top minus y bottom dx. That's step one. You decide whether it's y top minus y bottom dx, or it's x right minus x left dy. Step two. Fill in. What is y top? Y top is what y is equal to over there in the top of the strip. The curve. Y is equal to 4x minus x squared, all right, then minus y bottom. What is y equal to over here in the bottom of this strip? 0 dx. Step 3. Come up with the limits. Come up with these limits. Now, what these limits are is this. This is dx. This strip is moving this direction. So what is x equal to over here at the beginning? Well, this point is 0, 0. What is the x equal to over here? It's 0. So I'm going to go from 0 to. All right, this strip is moving over here to where? This point is 4, 0. What is the x equal to over here? 4. So we're going from 0 to 4. Caution. Caution. If this is dx, then these must be x's, and these numbers must be the x values. If this had been dy, we need y's in here, and these numbers have to be the y's. Okay, let me go back before I finish this now. Step 1. You come up with the rectangle, you draw it, and then you say, is that y top minus y bottom dx, or is that x right minus x left dy? Then you fill in. Step 2. What is y top of that rectangle strip? What is it equal to? What is y equal to? 4x minus x squared. What is y equal to in the bottom of the strip? 0. Okay, this step 3. Fill in the limits. Since this is dx, then I want to know what the x is on the strip. Where does it start? And what's the x where it ends? So x goes from 0 to 4. The rest of it now is integration. Okay, the definite integral concept that you're supposed to know. So integrating this would be 4x squared over 2. This would be adding 1 here. It would be x squared over 2 minus x3 over 3. Integration of x squared is x cubed over 3. And then you put a line right here, as you're supposed to know, from 0 to 4. And now you plug in. Plugging the 4 in here would be 4 squared, which would be 16 times 4. Now, you should have gone ahead and realized this divides out. So this would be 16 times 2, which would be 32, minus, putting a 4 here, would be 4 cubed. 4 times 4 is 16, times 4 is 64 thirds. Getting a common denominator here will be 96 minus 64 thirds, which is 32 thirds square units. You know, square inches, square feet, whatever this thing would be, because this is area. Okay? Now, let's look at example 2. Example 2 says this: find the area between all these curves. Y equals x cubed. Okay, that's the graph of that one. X equals 2. Y equals 0. That's just the x-axis. And x equals 0. That's the y-axis. So the area between all 4 of those lines is this area right in here. Now, let's draw a strip in there, a rectangle. Now, we'll draw a rectangle up and down. Drawing it up and down becomes the integration of y top minus y bottom dx. Okay, y top minus y bottom dx. Now fill in. Integration of what is y top? What is y equal to right up here? Y is equal to x cubed. So this will be x cubed minus what is y equal to down here? That's 0 dx. Step 3. Fill in the limits. This strip is going from here over to here. So x is equal to here is 0. X is equal to 2. So we're going from 0 to 2. And that's it. The rest of it is what you're supposed to already know, integration. Integrate this would be x to the 4th over 4 from 0 to 2. Plugging a 2 in here, 2 to the 4th power is 16 divided by 4 is 4. Minus, plugging a 0 in here would be 0, and therefore the answer is 4 square units. Now I'm telling you, this is all there is to finding area, and it's this concept. Number 1, you got to draw the figure and draw that strip either up or down or left or right. Now, at this point, I want to break from the notes and I want to talk about some examples. I could have drawn this strip this way. Now let's go back and look at the figure in example 1. Did I have a choice? Did I have a choice over here of drawing it? If I had drawn the strip this way, then what would be x right minus x left? It'd been the same thing. What is x equal to minus what is x equal to? Well, that would give us 0. We would be subtracting the same thing from the same thing. So the point then is this. This strip, when we draw it, must touch different curves. as that strip is moved from here to here to here to here to here, the top must be a different curve from the bottom of the strip. Well, that's true. As it moves over here, the top of the strip is different curve from the bottom of the strip. If I had drawn it this way, this side of this strip is the same as this curve. Okay? So let's go back now and look at example 2 and work it a different way. Let's now work example 2. If we had drawn the strip horizontal, if we draw it this way, now as that strip moves up and down, is this side of the strip different curve from this side of the strip? Yes, it is. So I can do it that way also. If I had drawn it that way, then it would be the integration of x right minus x left dy. The thickness of that strip is y's. It's this way. Okay? Step 2. What is x equal to? What is x equal to over here on this side of the strip? X equals 2. Minus, what is x equal to over here? Well, now, y is equal to x cubed. That says then if I take the cube root of y, I would have x. Okay. So the cube root of y would be equal to x. So x is equal to, right over here, x is equal to y to the 1/3 power. Y to the 1/3 power. Okay? Now, step 3. What are my limits? Since this is dy, I want to know what the y is here as this strip is moved up. So what is this point right up here? Well, if x is equal to 2 right here, x is equal to 2, what's y equal to? X is equal to 2, what's y equal to? 2 cubed is 8, so this would be 8. So now my limits are from 0 to 8. Now you better watch closely. If I have dy, I must have y points. Now we integrate. Integrating this, dy would then be 2y minus y to the 4/3 over 4/3 from 0 to 8. Putting an 8 in here, we get 16 minus, putting an 8 in here, what is the cube root of 8? The cube root of 8 is 2 raised to the 4th power is 16. So then this would be 16 divided by 4/3. Inverting and multiplying, we get, let's see, 4 will divide out here, 4 will be 16 minus 12 is equal to 4. We get the same answer as we got a while ago. All right, let's look now at example 3 in your notes. Example 3 says this. We want to find the area between the curve y equals x cubed, y equals 8, the x-axis and the y-axis. Now on your paper it says x equals 0, y equals 0. That's just another way of saying the x-axis and y-axis. So this is the area that we're looking for. Let's draw a strip this way, horizontal. Drawing it that way, our integration then is the integration of x right minus x left dy. Step 2, what is x equal to on the right side of that strip? What is x equal to on the right side of that strip? Well, y is equal to x cubed. If I take the cube root of y again, I have what x is equal to. So x right is y to the 1/3. Minus, what is x left equal to over here? Well, this is the y-axis, so x left is equal to 0 dy. Step 3. From where to where? This strip is moving from here to here. What's y equal to? Since it's dy, what is y equal to? That's 0. 2, what is y equal to? And that's 8. So again, integration now, y to the 1/3 would be y to the 4/3 over 4/3. And that's a 0, of course. Integration from 0 to 8. Put an 8 in here. What's the cube root of 8? The cube root of 8 is 2 raised to the 4th power 16 divided by that 4/3 again is 12. Minus, plugging a 0 in there, we get 0. So our answer is 12 square units. All right, these 3 examples, then, give the concept of drawing the figure and then drawing the strip either vertically, then it's y top minus y bottom dx, or draw the strip horizontally, then it's x right minus x left dy. The catch on that is this. You draw it vertically and then you move it across through the area and find out where it's touching the same curve at the top and the same different curve at the bottom as it moves. All right, let's look now at example 4. Example 4 says find the area between this curve, y equals x cubed minus 3x squared minus x plus 3, and the x-axis. Now, I just kind of skipped over this in example 1, 2, and 3 about where it crosses the x-axis and y-axis and that type of thing. Now we're going to look at the algebra that you're supposed to know to be able to work these. We've got then to graph that. We've got to know what the curve looks like so that we can set up the strip and the limits and that type of thing. So we need to know where the curve crosses the x-axis and the y-axis maybe. If we draw the strip vertically like this, we must know where it crosses the x-axis. If we draw the strip horizontally this way, then we've got to know where it crosses the y-axis. So we've got to graph that. Well, graph that. That's x cubed, synthetic division, to find the roots. So we've got to have then 1 minus 3 minus 1 plus 3. Find the roots. Now, if you don't know what I'm talking about here, this is where you go check out another tape that we have on synthetic division, finding the roots, and working through that. I'm not going to take that this time in this course to explain all this. I'm going to work it, but not to explain the reason and all that. All right, possible roots are plus and minus 1. So if I put a 1 here, it'd be 1 times 1, that'd be a minus 2, be a minus 2, be a minus 3. This times this be a minus 3, it's 0. Therefore, x equals 1 is one of the roots. So over here at 1, 0 is where it crosses the x-axis. All right, this is now x squared minus 2x minus 3. Factoring that is x minus 3, x plus 1. That tells us x equals minus 1. Okay, over here at minus 1, 0 is another root. X equals 3 tells us another root is over here at 3, 0. Now, let me back up for a minute and explain. If this is x cubed or x to the 4th or something like that, then you're going to have to use your synthetic division and algebra to find the possible roots. Okay? To find where it crosses the x-axis. All right, now you let x be equal to 0, and you get y equals 3. And that's where it crosses the y-axis. Alright, now, I don't care how you do this. You can plot other points or you can use your calculus. Take the first derivative of this. Taking the first derivative, we get y prime is equal to 3x squared plus 6x minus 1. Set that equal to 0 and solve for x and find maximum and minimum points. And finding maximum and minimum points, you get the curve up here is a maximum and a point down here is a minimum. Therefore, the curve is like this. You can use this if you want to. Another way of doing it, the way I do it, is simply this. If it crosses here and here and here, then all I want to do is to know some point in here, whether it's up here or down here. So, I just plugged in 0 for x and got it up here. So I knew this curve had to be like this. Then if I put a 2 up here, if I put a 2, I get 8 minus 12, that's minus 4, minus 2 plus 3, that's negative. Therefore, the curve is down here somewhere. And so here I have the curve sketched in enough to know this. This is the area that I want, and this is the area that I want. And that means I want to draw my strip vertical. So here's my strip drawn vertical. Now, listen closely. As that strip is moving across this area, is the top of that strip the same curve? Yes, it is. Is the bottom of that strip the same curve? Yes, it is. Now, it moves over here. Is the top of that strip the same? No. A while ago, the top of the strip was this curve, the curved one. Now the top of the strip is the straight line. That's not the same. Whenever this strip is moving across and the top of the curve, the strip, is not the same here, then you have to split it up. And therefore, we must work two problems. We must work the integration of this strip from minus 1 to plus 1, plus draw another strip. And now we work this strip from this point to this point. Now what I'm telling you is simply this. If you've got some of a curve area on the top of the axis and some on the bottom, you have to split it up. Hear that? One more time. When you draw the curves, you've got some areas above the x-axis and some area below the x-axis. You have to split it up and do the top part by itself plus bottom part by itself. All right, so let's set this one up. Okay, so let's do this. Drawing the strip this way, that is then y top minus y bottom dx, plus doing this one is y top minus y bottom dx. Now let's fill in. What is y top over here? Y top over here is the curve. What is y equal to up here? Y is equal to x cubed minus 3x squared minus x plus 3. What is y bottom equal to? 0. dx plus, what is y top equal to on this strip? What is y top equal to? 0. What is y bottom equal to? The curve. Minus, and you better put parentheses, minus x cubed minus 3x squared minus x plus 3 dx. You better watch this now. Alright, now let's come back and fill in the limits. Over here on this part, this strip is going from what's x? Minus 1 to what's x? Plus 1. So it's minus 1 to plus 1. Over here, the strip is moving from x is plus 1 to x is 3. From 1 to 3. Okay? Now, if you notice in your notes, here then I have the next step. We're going to integrate x cubed minus 3x squared minus x plus 3 minus a 0 dx from minus 1 to 1 plus this. Now, integration, x to the 4th over 4. 3x squared, this would be 3x cubed over 3. 3's would divide out, and you'd have x cubed. This would be x squared over 2. Integration of this would be 3x. From minus 1 to 1. Now, removing parentheses, this makes this a minus, this a plus, this a plus, and this is a minus. So we're integrating minus x cubed, and that's this. We're integrating plus 3x squared, and that's plus x cubed. We're integrating plus this, that's this. Integrating a minus 3, and that's this, from 1 to 3. Now, let me give you another trick on this that might be helpful. When you're plugging in, you go plug a 1 in here. This would be 1 to the 4th power, 1/4. Minus 1, minus 1/2, plus 3. Put all that in parentheses. Minus, put this in parentheses. If you're not careful of this, you're going to foul up and mess up on signs. Now, all in parentheses. Put a minus 1 in here. Minus 1 to the 4th power is a plus 1/4. Minus 1 cubed is a minus 1 times a minus is a plus 1. Minus 1 squared is a plus 1, and then it's a minus 1/2. Minus 1 in here would be a minus 3. Then I remove the parentheses, and I get a minus 1/4, a minus 1, plus 1/2, plus 3. Now, notice I don't add all this up in here. I just go ahead and leave it all that, because watch what happens. The minus 1/4 and plus 1/4 drop out. The minus 1/2 and the plus 1/2 drop out. So some of these will drop out and save you a lot of work. All right, let's continue. Plugging in a 3 here. This would be 3 to the 4th power is 81/4 minus that. Plug a 3 in here is 27. Plug a 3 in here is 9/2. Plug a 3 in here is minus 9. All that in parentheses, minus. All the rest of it. Put a 1 in here is a minus 1/4. 1 here is 1. 1/2. Minus 3. Removing parentheses, I get a minus 20 to the 4th, plus 27, plus 4.5, minus 9. Now this would be a minus, plus 1/4. Minus this would be a minus 1. Minus 1/2, plus 3. Now notice, here I've got 4.5 and a minus 1/2. So the halves drop out. Okay. Here I've got a minus 20 and 1/4 and a plus 4. The fourths drop out. And I don't have any fractions left now. And I don't have to work with all those fractions, common denominators. I just add up all these plus and minus numbers and come out, look here, I got a plus 3, a plus 3, and a plus 3. That's the same thing as that minus 9. That drops out. Okay? I got, which leaves me a minus 20 from a plus 27. That's a plus 7. Plus 7 minus 1 is a plus 6. Minus 1 is a plus 5. Minus 1 is a plus 4. And then I got this plus 4 and there's 8. And there I have my answer. If you use that trick, it will save you some work on stuff like this. Let's now look at example 5. Example 5 says, find the area between the curve x equals 4y minus y squared and the y-axis. Now, drawing the curve on here, we have some area on this side of the y-axis and some area on that side of the y-axis. That means that when I draw my strip this way, this x right is not the same as this x right when I get down here. So I must split it up. So I must do x right minus x left dy plus x right minus x left dy. Must split it up into two parts. So let's look at those two parts in your notes. The first part, let's look at the curve for a minute. The first part is this. Okay, from minus 1 to 0. From minus 1 to 0. So it's x right, which is 0, x left, what x is equal to. So looking at the notes, we have the integration of x right, which is 0, minus x left, which is the curve, what x is equal to, dy. Y values are minus 1 to 0. Plus this, And then we're going to integrate the top part. X right is the curve. X left is 0 dy. And then you can follow through the arithmetic. Now, this concludes then the problems for the area between a curve and an axis, a line. We're now going to look at the area between two curves. All right, example 6. We have the curve x squared equals 4y. That's this parabola. And the line x minus 2y plus 4 equals 0. We want to find the area between those two curves. So there's the area. Now, we've got to make a decision. Which way to draw the strip? Does it make any difference? Well, if I draw the strip here, what is y top? It's the line. What's y bottom? It's the parabola. As I move it across here, is y top still the line, and is y bottom still the parabola? Yes, it is. Therefore, we're going to draw our strip up and down. Now, what if I had drawn it horizontal? X right is the curve, the parabola. X left is a straight line. Now, move it down here. Still the parabola, straight line. But when it gets down to here, it's parabola, parabola. Same thing. Will not work. So I do not have a choice. It must be vertical, so that as it moves, y top is always the same curve, the line. Y bottom is the same curve, the parabola. Okay, so that makes our decision then. We want to know then the integration of y top minus y bottom, dx. Now we've got to come up with the limits. Where are the limits? What are these points? Where is this x and what's this x? We've got to do some algebra then. So we've got to solve these two equations. We want to find what x is equal to. So let's solve for y. Y on this curve is equal to x squared over 4. Y in this curve, well, we have x minus 2y plus 4 is equal to 0. I'm going to move the 2y across to the other side. Moving the 2y across over here and solving for y. Solving for y, dividing this by 2 would be 1/2 x plus 2. So y is equal to 1/2 x plus 2, and y is equal to x squared over 4. Now, I want to do this for two reasons. Number one is I got to find these points. But number two, what am I integrating? What y top is equal to. What is y top equal to? Y top is equal to that 1/2 x plus 2. What's y bottom? Y bottom is equal to x squared over 4. So you're going to have to solve for y's anyway. Now let's do some algebra. If y is equal to that and y is equal to that, then those are equal to each other. Okay? If two things are equal to the same quantity, then they're equal to each other. That says then that x squared over 4 is equal to 1/2 x plus 2. Multiplying common denominators, you get x squared is equal to 2x plus 8. Moving everything across to one side, you get it equal to 0. Factoring that, you get x minus 4, x plus 2. That says x is equal to minus 2 and 4. So this point is x is minus 2, something y, and this point is x equal to 4 and something y. I don't care what the y's are because I'm doing dx. dx. All I care is about what the x is and what the x is. Therefore, this strip is moving from minus 2 to a plus 4. Okay? Now, if you don't see that, back this tape up and follow through as I go through it again. You must do all this algebra to come up with the intersection points. All right, so let's look now at the final setup. Our setup then is, since it's vertical, it's y top minus y bottom dx. Well, what is y top? What y is equal to on the top curve. What y is equal to on the top curve. What's y bottom? What y is equal to. So y top is 1/2 x plus 2. Y bottom is x squared over 4. And since it's dx, then the values are going from -2 to +4. Okay? So integrating this. 1/2 x integration x is x squared over 2. So I get that. So that's the same thing as x squared over 4. Integration of 2 is 2x. Integration of x squared is x cubed over 3. So 3 times the 4 would be x cubed over 12. And then you plug in. Plug in the 4, work that out, then plug in the -2, work that out. It's in your notes. And it comes out to be an answer of 9. Okay, let's look at this one more time. What you must do when you have finding the area between two curves, you better draw it so that you decide whether the strip is vertical, and as it moves across, it better be touching the same curve at the top all the way across, and the same different curve at the bottom all the way across. If it's not, then you have the choice of moving it this way. Step 2, you better go find the intersection points. You do that by solving equations. You figure out what y is equal to, what y is equal to. Then set those two equal each other and do algebra. If it takes synthetic division, quadratic equation, or whatever it takes, you find where the intersection points is. Now when you find the intersection points, then you can set up the problem. You've got y top, y bottom, you've got what y is, and you've got the intersection points, and you can work it out. Alright, let's look at example 7. Example 7 is we want to find the area between the curve y squared minus 9 times x minus 4 and y squared is equal to 3x. Now, you're supposed to be able to graph this. This is y squared is equal to 3x. That's this curve. And this is y squared minus 9 times that. That's this curve. Now, if I draw my strip up and down, what happens? Y top happens to be the same curve as y bottom. So I don't want to draw it. I cannot draw it that way. And even if I move over here, now it comes out to even being a different y top and y bottom. So must then draw the strip this direction. Therefore, my integration is x right minus x left dy. So I got that decision. Now, what is x right? What is x equal to? I've got to go solve this up here for x. So let's look down here, solving that. We have y squared is equal to minus 9x minus 4. I'm going to divide by 9, not a minus. I'm going to divide by 9, both sides. That divides the 9 out. Then I'll remove parentheses here. And then moving this minus x across that side makes a plus x. Moving this across this side, I have... That's the algebra. If you don't understand that, you better back up the tape and study it again, but you should know this in this course. So x right is equal to 4 minus y squared over 9. That's what x right is equal to. So that's what we're going to get to plug in here. Now, what's x left? X left is, you can solve it right here. X is equal to y squared over 3. So x left, y squared over 3 is what we're going to get to plug in there. Now, what are the limits? That's the intersection. If x is equal to that and x is equal to that, then those are equal to each other. Those are equal to each other. So 4 minus y squared over 9 is equal to this y squared over 3. Moving across this side, we have 4 is equal to y squared plus y squared over 9. And then common denominator, that's 4y squared over 9. Okay. Dividing the 4 out from both sides leaves us 1. Multiplying the 9 across makes it y squared is equal to 9. Therefore, y is equal to minus 3 and plus 3. So, this point down here is 3 minus 3, and this point is 3 plus 3. Well, I don't care about that first number. I'm just putting it in there. This y value is a minus 3, and this y value is a plus 3. Therefore, I'm going from a minus 3 to a plus 3. Since it's dy, I need to know what the y is to what the y is. All right, looking in your notes, let's look at the setup completely then. I had to draw the strip right and left, therefore it's integration of x right minus x left dy. What is x equal to? It's 4 minus y squared over 9. What is x equal to? Y squared over 3 dy. Now, in step 3 then is coming up with the limits. And let me say one other thing. You've probably heard this, but I'm going to say it one more time. Since this is dy, two things must occur. Number one, the numbers over here must be y numbers. Number two, all these letters must be y's. Now see, we have x right minus x left, dy. We can't have x's in here. Since this is dy, we've got to say, what is x equal to? What is x equal to in terms of y's? What is x equal to so that we have y's? And then you integrate. Well, this can be combined here. Minus y squared over 9 minus y squared over 3. Common denominator is 9. You get a minus 4y squared over 9. Integrating that would be 4y. 4y cubed over 3 times 9 would be 27. And then you go from there. You can follow your notes. All right, let's look now at example 8. Example 8 says find the area between the curve y equals x squared and y equals x cubed minus 2x squared. Now, again, y is equal to x squared. You got to draw that parabola. If you don't know how to draw parabolas, if you're having trouble with these curves, you need to go back and check out some other tapes. We have a tape on parabola. We have a tape on graphing, synthetic division, all this type thing. Okay, so graphing this curve, we come out with this one. Graphing this curve, the parabola one, we come out with this one. Make these a little difference in size so it's obvious which one we're talking about. Okay. All right, now draw the strip. Well, if we draw it this way, we're touching the same curve. If we draw it this way, top is the parabola, the bottom is the cubic. Parabola, cubic, parabola, cubic, parabola, cubic. So we then can draw our strip up and down. Therefore, that's y top minus y bottom. So that helps us that decision. Our decision is y top, y bottom, dx. Since it's dx, we've got to get x numbers here and here. We've got to get what y is equal to in terms of x. Well, what is y equal to in this one? Y top is equal to x squared. Y bottom is equal to x cubed minus 2x squared. We got that. Only thing left then is intersection points. Well, again, if y is equal to this and y is equal to this, therefore this is equal to this. Two quantities are equal to the same thing, then they're equal to each other. So x squared is equal to x cubed minus 2x squared. Moving this across, set it equals 0. Moving this across makes minus 3 of those. Factoring out of x squared leaves us x minus 3. That says x equals 0 and x equals 3. So our intersection point is here at 0, 0, and here at 3 something. I don't care what the y is. I just need to know, since this is dx, what the x's are. This point is 0, 0, so I know what this x is and know what this x is. Therefore, let's look up at the setup. The setup in your notes is integration of y top minus y bottom dx. What is y top? Y top is the parabola, x squared, what it's equal to. What is y bottom? It's the cubic. What is it equal to? It's x cubed minus 2x squared, dx. Step 3, what are the limits? We've solved that. The limits are going from 0 to 3. Now, removing a parenthesis here, this would be a minus x cubed, and this would be a plus 2x squared, and this one make a plus 3x squared. Integrating that would be a minus x to the 4th over 4. Integrating that would be 3x cubed over 3. The 3's divide out. You get a plus x cubed. And then you plug in. Plugging in 3 here will be 81/4 minus 81/4 plus 27. Plug in a 0, you get a 0 plus 0. And working all that out, you get 27/4. All right, let's look at this last example. It says find the area bounded by the curve x plus y equals 3, 2x minus y equals 4, and 6x plus 3y equals 3. So we have to graph. We draw the line 2x minus y equals 4. We draw the line x plus y equals 3. We draw the line 6x plus 3y equals 3. And here then is the area. Now, if we draw our strip up and down, it touches this curve and this curve. But now over here, it's two different sets. This is curve 1 and 3. This happens to be 1 and 2. That's a different set. Y top, Y bottom is 1 and 3. Y top, Y bottom is 1 and 2. That's different. So that means let's try it this way. Trying our strip this way, that's curve 2 and 3. But as it comes up and it goes past this point right here, it now becomes 1 and 3. So no matter which way we draw it, it will not touch the same curves all the way. So then we just come back and separate it into two problems. We will now work it from here up to here. That means we're going to integrate x right minus x left dy from this y value to this y value. Then we're going to integrate from here, this y value, whatever that is, to this y value. So we must, in this problem, split it up into two parts. And there are problems like this, that no matter how you draw the strip, it won't stay on the same two different curves all the way across. So, splitting this up then, first of all, we better find where these intersect. We need to know what this point is, and what this point is, and what this point is, so we'll know our x and y's. All right? For this intersection, it is the solving of the simultaneous equations of this line, x plus y equals 3, and this line, 2x minus y equals 4. Solving that by simultaneous equations, that you're supposed to know how, you come up with x is 7/3 and y is 2/3. Okay? Then right here, we will take this line, which is the 2x minus y equals 4, and this line, which is a 6x plus 3y equals 3, and we will solve those simultaneously, and we get x is equal to 5/4 and y is equal to a minus 3/2. All right, then we come over here and we find the intersection of these two. This is x plus y equals 3, and this is the 6x plus 3y equals 3. Solving those, we get x minus 2, y 5. Now we can set up our integration. So you look at the graph there, and that means that we have to do the integration of x right minus x left dy for this part, which means from 2/3 to 5, where x right is what x is equal to on this line, what x left is equal to on this line. We'll do that. We'll also add to that the integration of this x right minus x left dy from this y minus 3/2 to this y 2/3. X right is what x is equal to on this curve, and x left is what x is equal to on this curve. Now look at your notes and then the setup on the integration. That says that we will have the integration of x right, that's curve number 1, minus x left, that's curve number 3, dy from 2/3 to 5, plus, and then we just do the other part, that x right is curve number 2, minus x left, which is curve number 3. dy from minus 3/2 to a positive 2/3. Now you can watch the rest of the arithmetic. You can look at it on your notes. I have it worked out, finished out for you. Let's go back and look at the graph of this one and realize what I'm saying. I'm saying that all the problems I worked here, nearly every problem you work in your homework, is you draw that strip, and if you draw it correctly, it will take care of one integration, all the way across or all the way up and down. You do everything. However, there are some problems, no matter how you draw the strip, vertically or horizontally, as you move it, it changes curves. Therefore, you must break it into parts and do one part, then another part, and so on. This then concludes the tape on area.